Okay, welcome Ross and welcome Alex and anyone else who's watching this as an archive video. Thanks for coming on in. The plan today is we're going to be looking at chapter 11. What we haven't done yet, and this is what we're doing today, is dealt with qualitative variables. So when you have any kind of survey question or study where you don't have a number answer, and that happens all over the place, we still want to be able to run statistics. We're limited on what we can do, but there's still some stuff we can do, and that's called chi-squared. So it's great for understanding if distributions are the same or if one group is similar to another in their answers. That's what we're going to be looking at. So a couple notes. One is a week from Sunday. What's coming up? See if you're both paying attention. So you can say it or put in the chat box. What must be done by a week from Sunday? Ross, Alex? Yeah, project 2. So project 2 is due a week from Sunday, but that doesn't mean you should start a week from Sunday. That won't work. So just to note, a few people have already posted in the project 2 discussion board and talked about what they are planning to do. And I've already put in my comments for improvement, or if it works or if it doesn't work, and if it works, what's kind of next steps. So I recommend everybody do that ASAP, because again, you want to make sure you have a good idea that's going to work before you go and do it. So if you do that now, then that should give you enough time to work things out. Also, what I recommend is a week from tomorrow to send me, or it could be earlier than a week from tomorrow, but by a week from tomorrow, send me your draft of your project 2. And then I can send you suggestions for improvement. Just a couple notes. Very important is that pretty much all over the place, you should have the word population means. Okay, those words need to come up over and over again in your project, because that's what your project is about. So let you know that's some vocabulary that you need to pop in, because this project is all about comparing 2 different population means, whether it's independent or dependent. So anyway, some notes about your project. I'll be happy to answer any questions you have, either now or if you post in the project discussion forum, and we'll make that happen. Any questions so far? Zach, thanks for showing up. Any questions about the project or about anything else we've been doing in the class so far? Any questions? Okay, if there's no questions, what I thought I'd do, and today may not even go that long, we'll see. Certainly isn't going to go a full hour and a half, because we just have one chapter. There isn't, I can talk about project 2, but this chapter, by the way, is not part of project 2. Don't even think about doing chi-squared qualitative stuff. The project must be quantitative. So this is a different chapter. The idea is you should already have your idea for project 2 before you even hear me talk about this. So what I thought I'd do is I would share an article. And what we're going to be doing is this chi-squared analysis really is only done in full peer-reviewed projects and papers. So I need to share something that looks like a peer-reviewed project. I'll show you some less realistic things after as examples, but I want to show you what an example really looks like. So let me do that. And that is, let me go find it. I think it's maybe that one. Let's see. Yeah, good, got it. Okay, and this comes from, this is a peer-reviewed journal. I just did, by the way, this is from the LTCC. The nice thing is they pay some money to be part of this group that can get pretty much any peer-reviewed journal. Okay, or not any, but many, many different peer-reviewed journals. So I looked up, and I'll tell you honestly, I decided I wanted to do something that was relevant to all of you guys, so I thought I'd look up just student majors. And I just search that in the database that they've got in EBSCOhost. And the very first article that it popped up had a chi-squared test. They are very, very prevalent in journals. So it's not that much to ask you to find a journal article that includes a chi-squared analysis, because they have them. And notice, by the way, statistics is not kind of the main point of this journal article. The main point is to look at good and bad reasons for changing a college major and comparing student and faculty views. Okay, notice the word chi-squared is not in it, and it must not be in your post, by the way. So I really wanted to look at something that just uses chi-squared, and that's what I want you to do also in this week's assignment. Okay, so let's take a look at this article. So first thing, again, I read the title. You can read it also. I'm not going to read the whole article. It's long. But I will let you know a few things. What they did is a bunch of things, but talked about why do students change their majors and disadvantage and advantage of changing their majors. How do students and faculty view it? Is there a difference between the two? Et cetera, et cetera. Let me look at the method. Okay, participants came for a large public university. It's definitely not LTCC. We're a tiny, tiny public university. Okay, in the southeastern US. Notice that they had N is 125. Do you think 125 is large enough to run statistics? What do you think? Again, it's time to go back and think about all the stuff we've done in this course. So yes or no? Alex or Zach or Russ? Do you think 125 is a large enough sample size as a possibility to do some statistics on? I don't see y'all jumping in, but let me know. Okay, you'd need NP and NQ. They did a lot of questions. So if they're asking for things that are not that rare, you kind of assume that, then what do you think? Is 125 big enough? Or if they're asking for quantitative data. So any thoughts? Okay, it turns out it's usually big enough to do statistical analysis, but it's not usually big enough to have a satisfactory confidence interval, for example. Remember, you need around 1,000 for a good margin of error. I don't know if you remember that. So again, it's good to look at things and say, well, this isn't the biggest survey in the world. It's not so minuscule that we shouldn't even read the article, but they could have done better. Any questions on that first? Okay, so, and I'm not going to read all of this, but we can look at a bunch of stuff. So for example, in the procedure, all participants completed a survey using a commercial online survey program. Took 15 minutes, and then they got a thank you note. Okay, and the questions they asked, and this is important, participants rated it on a 5-point Likert scale. Now, I don't know if you know what a 5-point Likert scale is, but it comes up a lot, and you've seen them before. So a 1 is strongly disagree, a 5 is strongly agree. There's a 2, 3, and a 4. Okay, so a 2 would be a disagree, a 3 is neither disagree nor agree, and a 4 would be agree. Notice that this survey is qualitative. Do you agree with this? I strongly disagree. It's really not quantitative. You're not taking an average of these things. You're looking at their agreements. Any questions on that idea? Okay, so this survey is qualitative. It's not even a yes-no, because there's 5 different choices to choose from. Okay, then, for example, it says under descriptive statistics, the number of students that reported they had changed their major at least once as an undergraduate, N equals 98, 79%, was significantly higher than the number who never changed their major. N is 26, 21%. One was missing. Okay, then they report that chi-squared is equal to 41.81, and the p-value is 0.001. All right, even if you don't understand chi-squared, that's what we're doing today, I'm hoping you can tell me what does it mean when the p-value is less than 0.001. What does that tell you? And that's something that you're all supposed to know, because that's not new at all. I've been doing it for a few weeks now. Okay, so if the p-value is less than 0.001, what can you say? So Alex and Zach and Ross. Yeah, then we know that it is statistically significant. It's actually strongly statistically significant, because this is a very small p-value, right? It's not just less than 0.05, it's really small, okay? So that means they definitely have statistical significance, okay? So that means they can say there is a difference, okay, between the number of, or the percent of students who changed their major at least once as an undergraduate and those who never changed. Any questions on that? Any questions? Okay, we're not going to go through all of this, but notice that there's other statistics given that we're not doing today over here. But then the next one, which I'll talk about, the number of faculty that reported they had changed their major at least once as an undergraduate was slightly higher than the number who had never changed their major. But now chi-squared is 0.19 and the p-value is 0.66. So what do you think now? So if the p-value is 0.66, what do you think now? And this should be pretty easy to know. Yeah, now it's statistically insignificant because the p-value is very high. In fact, I worry about these authors that say that, you know, it was slightly higher. They should just say it's statistically insignificant. We know nothing about the population. Does that make sense? Okay, I don't want to diss the authors too much, but I don't think they concluded well. Okay, so again, I'm not going to go through all of this, but they did another one, a chi-squared test for independence. The faculty and students differed significantly in their frequency of having changed their academic major. Okay, now we have, again, a p-value is less than 0.001, another chi-squared test. Today's all about chi-squared test. Okay, so for this one, again, hopefully you know this is strongly statistically significant. And here's a new thing that I really want to emphasize. This is a test for independence. Okay, so a test for independence, what that means is that our null hypothesis is that the answers are independent of whether they're faculty or students. Whereas if you got an H1, looking at the H1, is that it is dependent on whether they're faculty or students. Any questions on that? And that's what today is all about, is looking at these chi-squared tests, writing down the null and alternative hypotheses, finding the p-value, and making the conclusion. As you'll notice, that's pretty much what the last half of this class is dealing with a hypothesis test, and that's the steps of the hypothesis test. Any question before I move on? And notice they do a lot of different hypotheses. Goes on and on and on. I'm not going to read through all of this, but look at all these p-values they have. Again, I'm not going there. These are t-tests, and you've already learned about t-tests. Okay, any questions at all before I move on to kind of more stock questions? things that I'm going to ask you to do on exams. Okay, this is what I'm going to ask you to do on the discussion forum, where you're going to have to post something that has a chi-squared. You can't use this one, by the way. Don't use my article. There's millions of articles out there. Don't use this one. Just a note, when you're before you post your article, I strongly recommend getting a piece of pencil and paper out and make sure that you can write down the null and alternative hypotheses and then your conclusion. If you can't do that, it may not be a good article to post. Then what you should do is not just post the URL, but these are long, okay? This is a 15-page article and it's pretty intense. Help your students, guide them to where the chi-squared and p-value is located in the article. Otherwise, you're making them read a very long article that might be too hard to read. Okay, so help your fellow students. If you can't find it, then don't post that article. And if you can't answer and analyze it, it's probably not good enough to do. Okay, so make sure that you can do your own post before you post it. Okay, don't post your answer, just write it on a piece of paper. Any questions on that? Okay, so now let me reshare, and we're going to do a more stock questions from now on, if that's all right. But if you have questions, please let me know. And let me pop a question in. Okay, so here's a sample question. And I know some of you aren't from Tahoe, but Ross, you are, because I just saw you. But I'm not sure about Alex and Zach. I know, Zach, you're very far away right now. But the question states, is the traffic equally bad in the north, south, east, and west shore? So in our town, at least, that's usually how they talk about the different areas of Lake Tahoe, north, south, east, and west. Okay, a count of 600 randomly selected cars in the Tahoe Basin found 170 in the North Shore, 212 in the South Shore, 110 in the East Shore, and 108 in the West Shore. Conduct the appropriate hypothesis test and provide your interpretations. Okay, before I do this, let's look at the survey question. Okay, you're gonna, or the data that you're collecting. You're gonna look at a car, and what are you gonna write down about that car? See if you can say it or type it in the chat box. What are you gonna write down about that car after you've looked at that car? So what are you gonna write down? Yeah, where does, give me an example of something you might write down. Yeah, so what might you write down? What word might you write down? Yeah, or letter, N is fine. You might write down north or east or west or south. Notice that the answer to the survey question is a word, and not even a yes or no word. It's a true, just qualitative word. And that's something we've never done in this class before in terms of a hypothesis test or even a confidence interval. Do you agree? Okay, when we're dealing with this qualitative kind of data, that's when we do chi-squared. So this particular one, in our class, equally bad. Okay, we want to find out, is the traffic equally bad? If it's equally bad, we have a word for all things being equal. What word did we use in our class when everything was equal? Equally distributed, but what word did we use? Do you remember? We had a whole chapter basically on it for this distribution. Normal's not equal because remember, in the center it's very common, but then if you go far from the center it's very rare. Does that make sense, Ross? It was a good try. Normal was really important. We did have a whole chapter on that. But what chapter we had where whether you look center, left, or right, it was all the same. It was all equal. Yeah, X tilde U or uniform. All right, so the first thing is in this chapter, and you need to promise me something. And by the way, I noticed not all of you keep your promises. And when you don't keep your promise, you lose points, by the way. Promise me that when I ask for the null alternative hypothesis, in anything from chapter 9 or 10, you will not write down words. So I want to hear you say, I promise. So you say it, because it's really important, and it's a big mistake I see students make. Is that once you learn about words, you don't want to use symbols anymore. Okay, but the prior stuff, we use symbols. Now we're going to be using words for this. Every chapter before now, we do symbols. Yeah, so 9 and 10 are symbols, whereas 11 are words. 12 will be symbols again, by the way. Okay, and 13 is half and half, but we're not there. We're not even close to there yet. So what I want to do is write down the null and alternative hypotheses, and these are going to be done in words. So we're going to have H naught, and that is the distribution of traffic in Tahoe, or the Tahoe Basin, is uniform. Any questions on that? Okay, I want to know a very important word, and I will take off points if you don't have this word, and that is the word distribution. When we're doing a chi-squared test, okay, for what's called goodness of fit, because that's what we're doing, then you have to have the word distribution because it's all about the distribution. H1. Hi, Tia, thanks for showing up. We're just in the middle of an example. I'll let you read through it. And that is the distribution of traffic in the Tahoe Basin is not uniform. Any questions on H0 and H1? Okay, the test we're going to be using is called a goodness of fit test. So let me write that down in red because it's important. Sometimes it's called a chi-squared goodness of fit test. We've seen the distribution normal, we've seen uniform, we've seen binomial, we've seen T. Now we got a new one, and the distribution we're going to be using is chi-squared. Okay, so our test statistic will be a chi-squared test statistic. You do not need to know the mathematical details of it. I just want you to know the words. So we call it a chi-squared distribution, and the test we're using is a chi-squared goodness of fit test. Any questions so far? Okay, the next thing we're going to do is I'm going to draw a t-table. And maybe I'll even do like so. And what we get in our t-table is the first thing. We're going to have our north, I'll just use N. Going to have south, I'll use S. I'll use E for east. And I'll use west, W. And that will be the column labels. And now let's write down the row labels. And that is going to be observed and expected. Any questions so far? Okay, next we're going to put in our numbers. So in terms of our numbers, we observed in the Tahoe Basin in the North Shore, there are 170. In the South Shore, there were 212. In the East Shore, it's not numerical data. It's a good question, Alex. Chi-square is not for numerical data. This is not data. These are counts. Do you see the difference, Alex? The data is a bunch of N's, S's, Easts, and Wests. Now, what the table is saying is how many N's did we get? How many S's did we get? How many E's did we get? And how many W's did we get? Does that make sense, Alex? But the survey question is, what shore are you on? And the answer would be East Shore. And what this table shows is how many people said what. So this is a frequency table of the qualitative study. So there were 110 the East Shore and 108 on the West Shore. So this is the raw data, not what they want. I'm not sure what you mean by what they want on this. These numbers that I just put in the table, those are frequencies. The raw data might look like north, east, east, north, north, south, west, west, north, east, east, south. That would be the raw data. Does that make sense, Alex? And what we're doing is we're making a table to summarize the frequencies of the raw data. But the survey question is definitely qualitative. Okay. And again, these are good questions, so please keep asking. And if you don't understand what I just said, please ask again. So now let's go to the expected. So so the idea is if H naught were true, because that's hypothesis testing that always works. When you're computing a p-value, you're saying, well, if the null hypothesis is true, how many would you expect to get? So if it was true that the distribution of traffic in the Tahoe Basin is uniform, how many would you expect to find, how many cars of the 600 would you expect to find in the North Shore? Yeah, 150 in the North Shore. Okay, and then all the rest would also be 150, because that's how uniform works. So let me write in our expecteds. So it's 150, 150, 150, and 150. Any questions on that? Any questions? Okay. And that's because H naught has to do with uniform. It won't always be uniform, but this example is a uniform example. So we're testing to see if it's uniform. Notice that, we got 170. When the expected was 150, we didn't get what we expected. Does that mean it's not uniform? What do you think? Right, we expected 150, we got 170 for this first one. So does it mean it's not uniform? Okay, the key word is it. Okay, it's a very ambiguous question. We can say that the sample is not uniform. Does that make sense, Ross? But the population we don't know because we only looked at 600 randomly selected cars. We didn't look at all the cars that ever happen in Tahoe, which are millions. So the question is this far enough away from being uniform to say that there's statistically significant evidence that it's not uniform for the population? That's what statistics is all about, is you use a sample to make an inference about the population. Any questions on that? Okay. It could be normal, but we don't care about normal. This question is about uniform. So is it uniform or is it not uniform? It's all we care about with this one because that's what H0 and H1 are. Okay, now comes the next part, and this is where you cross your fingers big time. Did you bring your calculators with you? Okay, so get out your calculator and at the same time cross your fingers and say a prayer or something. Because if you get lucky, you got it. If you don't, then it might be a pain in the butt. So hopefully it does, because unfortunately, even if you have a TI-84, for example, it doesn't mean it works. So TI actually changed their production halfway through the TI-84 building. Okay, 83s don't work, by the way. And so we'll see. So I'm going to go to the calculator, and we'll see if you have what I've got. Let's go to share. Okay, so here's the calculator. And follow along, and let's hope you have what I'm showing you. So I know you have the first thing we'll do, what you all have, is we can go stat. We can go enter for edit. Okay, now we're in the case where we have two columns. Okay, we have the observed and the expected. So I'm going to clear out L2, and I'm going to clear out L1. We did this in the last chapter also. We had two columns. Then I'm going to type in my observed for L1, and the observed, if you remember, were 170. Then it was 212, and then 110, and 108. And the expected were all 150. Oops, 150. Any questions on this? Okay, this is something you should all have. Hopefully you were able to type it in also. I tried not to go too fast. Okay, then what we do, this is where you cross your fingers big time. You go to the stat button, and you go to tests. Okay, we're towards the end of the class now. So it's towards the bottom of all the tests. So it's easier to go backwards from the bottoms. Because if you hit the up arrow, then you might see, I hope you see, this one right here where it says GOF. Do you have it? Okay, you do, Tia, so you can smile. Oh, good. You can smile too, Ross. Hopefully, Alex, you got it. Good, good. Lisa's group and Zach, I have no idea if you've got it or not. If you don't have it, I have a link in the modules to be able to program it into your calculator. It's a pain in the rear. Or if you happen to be in Tahoe, you can come. Oh, good. Zach, you have it too. So you're all in good shape. Hopefully, the rest of you are watching this as an archive webinar have it too. If you don't have it and you live in Tahoe, come to my office during office hours. In 10 seconds, I can put it in your calculator using my calculator, and we have them mate, and then I send it in. Otherwise, you have programming to do. Okay, but there's step-by-step programming video that I posted. All right, so I hit enter on chi-squared GOF. Okay, if it doesn't already say so, the observed should be L1 because that's what we put in, right? The expected should be L2. If it doesn't say it, make it L2. By the way, L2, second 2, L1, second 1. DF, just let you know that stands for degrees of freedom. So the degrees of freedom is always one less than the number of categories. So in this case, remember we had north, south, east, and west. There were 4 categories that the cars could be in. So if you take 4 and subtract 1, you get 3. So the degrees of freedom is 3. Any questions on that? Color never matters. You probably don't have it in your calculator, and don't worry about it. Okay, are you good? Let me know if you don't want me to hit calculate yet. Give you a couple seconds to make sure you're following along. Okay, calculate. Okay, so first thing, this right here kind of looks like an X. That's not an X. Okay, it's a Greek letter chi, C-H-I. It's pronounced chi. It looks like chai or chi or something like that, but everyone pronounces it chi. So we call it the chi-squared distribution. So when I ask you for the test statistic is 50.72. Any questions on that? All right, is the p-value 5.61 dot dot dot? Is that the p-value? Do we say the p-value is around 5.6, so that's really big? What do you think? Any thoughts? Okay, yeah, don't forget, it's a scientific notation. See that E negative 11? That means we got to move the decimal over 11 places to the left. P-value is basically 0. It's as close to 0 as you get. Does that make sense? Okay, so now let me reshare so we can actually write down our conclusions. So what we can say, first thing, I'm just going to write the P value. Often you'll just see P. I like to write down the word value because we have P for lots of different things. So I think it's a little more clear if you write that down. I'm just going to write less than 0.001. That's kind of what's done in literature. It's a really small p-value. It's actually less than 0.00000000001. Okay, it's tiny. Any questions on that? Okay, now if the p-value is 0.00, less than 0.001, what's the conclusion? Any thoughts? Zach, Ross, or Tia? Yeah, we reject H naught, and there is statistically significant evidence. To support the claim that, and now you just rewrite H1. The distribution of traffic in the Tahoe Basin, Bain Basin, is not uniform. Any questions on this? Any questions? Okay, just want to let you know, wording is not optional. I need to see the word statistically significant. I need to see the word uniform. I need to see the word distribution. I noticed on, for some of you on your midterms, you were not putting words like population mean on and statistically insignificant or statistically significant. Those words must be there in your conclusion. When I ask you, what is the conclusion, or what can you say, that kind of thing, you need to have the proper language. Vocabulary is essential in this class. So again, when I was grading the midterm, I noticed that some of you got it, some of you didn't. So make sure you practice writing. Okay, it's all in the assignments, but if all you do is read and check which one you like, you're not practicing writing. Make sure you're writing it too. Don't just click a check when you do the homework. Okay, and it's also, you're going to have to do this type of thing in your the assignment for the discussion post for this week. Any question before we do another example? Okay, I want to mention a couple things because I don't have time to do every type of example. Again, this is about uniform. Sometimes, what's another distribution you want to find out if it's like? Not in this case, but in maybe some other case that you might be interested in seeing if it fits some distribution. But something else might fit a distribution. Any thoughts? Not this example, but other examples. I don't see you all jumping in. Maybe I'll say it, but I'm hoping you answer. Okay, the big distribution of the whole quarter, and that's a normal. And that's when you put things into categories. Okay, so categories like, 5 to 10, 10 to 15, 15 to 20. And if you put it in categories, you can use this chi-squared to test for normality. And it's very important to know, because if you have a normal distribution, then you have all kinds of things you can do with statistics. The other big distribution that you're often comparing with is to find out if the distribution this year, for example, is the same as last year. Or maybe for men is the same as for women. Or maybe for California is the same for New York. So a lot of times you're looking at those kind of distributions. Any questions before I move on to the next type of chi-squared test? I'm about to erase all of this, so last chance. Going once, twice, gone. Okay, let's do another example. Okay, I think I was in a car mood when I wrote these, but that's okay. A study was done to see if there's a difference in the distribution of cars for men and women. Okay, if you think about what car men own and what car women own, is there a difference? Or doesn't matter what gender you are, you're going to own the same kind of car, basically. Okay. Of the 200 men surveyed, 70 owned a foreign car, 110 owned an American car, 20 did not own a car. Of the 300 women surveyed, 110 owned a foreign car, 158 owned an American car, and 38 didn't own a car. How does this differ from the one we just did in terms of the information given? It's very important, because the hardest part about this class from now on is deciding what kind of test to use. And as you might guess, there's going to be a different test for this one. Why can't we use what we just did, which was goodness of fit? Any thoughts? So goodness of fit won't work. Once, twice, no ideas? Okay, what's going on here? In the goodness of fit, what you're doing is you take one sample, you look at the categories for that sample, and you compare it from some known distribution like uniform or normal. This is not one sample. These are two samples. We got men and we got the women. We're not comparing it to some known distribution. We're comparing two unknowns to each other and seeing if there's a difference between the two unknowns. Any questions on what we did before in the first example and in this second example, and how we can't use goodness of fit for this? Any questions? We still want to see if the distributions are different, but now it's two unknown distributions, not a known versus an unknown. And when you have that, the test we use is called a test for homogeneity. Sometimes called a chi-squared test for homogeneity. It turns out the math behind it has some similarities. You're still going to use this chi-squared number. Any questions so far? Okay, we don't have observed and expected anymore. Now we have men and women. but we're still seeing that the distributions are different. So what we can do is we can write down H naught and H1 kind of a similar way to each other. So H naught is the distributions of car types are the same for men and women. And H1 is the distributions of car types are not the same or are different. Or how about even easier, differ for men and women. Any questions on this? Okay, the keyword is almost the same, but it has one extra letter, right? The keyword before was distribution. Keyword for homogeneity is distributions, because we're comparing two distributions that we don't know either of. Any questions so far? Okay, we're still going to draw a table, but we don't have observed and expected anymore. Now what we have, there wasn't a question. Yeah, I decided that I needed the space, so I didn't put in a question. On a homework problem, I would put a question in. But here's a study, let's understand it. Do you see, we want to find out if they're different. We're comparing men and women. That was supposed to be kind of obvious in just the study itself. Yeah. And again, I only have so much real estate on this screen, so I try not to overwhelm you guys. So that's why it's not exactly what you expected. Just need a little lower. Okay, so similar. Now I'm going to write in. So our different types, if you remember, I'm just going to write, how about FC for foreign car? How about AM for American? And then none. And then we have men and women. And I'll use M for men and women for W for women. Okay, then in this case, it's all observed. So the male numbers were 70, 110, and 20. The women numbers were 110, 158, and 32. Any questions so far? Okay, so the next thing we need to do is we need to go to our calculator. And the good news, doesn't matter for you guys, but for everybody else, is that all calculators can do this. Okay, all of the required calculators can do it. So let's share I want to share my calculator. Okay, this is going to look totally different. Just let you know. It's going to be completely different. So what we're going to do now is I am going to go to second matrix. Okay, this is new buttons for y'all. So I'll stop a moment. That second matrix is right here. Then I'm going to go over to edit. And on A, I'm going to hit enter. And what we want, if you remember what it looked like, we had 2 rows and we had 3 columns. Remember that? So the 2 was correct. Enter on 2, and 5 should be a 3. So this is a 2 by 3 matrix. Any questions so far? Then I put in my data. So again, we had 70 for men foreign. I hit enter. And then we had 110 for men American. And then we had 20 for men none. Okay, and then for women, we had 110 for foreign. We had 158 for American. And then we had 32 for didn't own. Whoops, I missed. Sometimes it doesn't register the number I type in. There we go. Any questions so far? So again, this is a second matrix, very new. We haven't done this before. All right, the next thing we do, now that we have our matrix typed in, is I go to stat. And then I'm going to go to tests. This is not the chi-squared GOF. This is just chi-squared. So it's that chi-squared, it looks like x squared, test. Okay, very important you know which test to use. Then I hit enter. Observed is A, expected is B. Just a note, I'm not going to get into the mathematics of how you compute the expected. It's actually the square of the difference and then divide by the expected. Okay, and then you do some more work and you can get your expected values. But I'm not going to show you to do that, but that B is going to tell you something. If you type in B later on, then you have to make sure all the numbers are bigger than 5, and that's our sample size criterion, is that all the expected numbers must be bigger than 5. For goodness of fit, all the expecteds must be bigger than 5. We saw the expected, that was easier. Here, the calculator does the expecteds. So expected is B, and I go to calculate. And there we go. Chi-squared is about 0.265765. And the p-value is about 0.876 or so. What do you think? What does that tell us? Any thoughts? So this is something you guys should know now. Our p-value is 0.88 about. Yeah, it's definitely not statistically significant, not even close. Okay, I want to also mention that typically the level of significance is not given to you because it's just clear. You look at the p-value and you know how to conclude. And then you use things like there's definitely insignificant evidence. Had you gotten a p-value of, say, 0.07, you might say there's weak evidence. So again, you don't have to be given the level of significance now to be able to understand what kind of evidence you have. So now let's go ahead and make the conclusion. There is statistically insignificant evidence. To make a conclusion whether or not the distributions of car types are the same for men and women. Just a note, by doing the whether or not, then I can just go for the same. Otherwise, I have to say differ for men and women. But that only works when there's insignificant evidence. If it was significant evidence, then you would just have to say that there's significant evidence to conclude that the distribution of car types are different for men and women. Just a note, here's something we're not doing. We're not saying what's different, okay? In the last example, we had statistically significant evidence that it was not uniform, but we didn't decide whether it was a north, south, east, or north. North, south, east, or west that was making it not uniform. And I'll let you know that can be done, but that's in not elementary statistics. That's in an advanced statistics class. So we're not doing that in this class. You could do something called a Tukey analysis. I'm just not going into there. Okay, but there are ways of doing it, just not in our class. Any questions at all about this example, this test for homogeneity? Okay, when I ask you, notice I say when for the name of the test for homogeneity is the name of this test. Any questions on that? Very important to know that. Okay, let's do another example. And that'll be the final example. There's 3 different main tests to do in this chapter. So let me do the third one. The third one is looks a little about both. Okay. Let's see if this works. I think it worked. I never know if the table is going to show up well. Okay, so here's the question. Is there a relationship between the day of the week a person is born and the type of smartphone they own? Okay, the table below shows results of a study that was recently done. Conduct the appropriate test and provide your interpretation. Okay, so notice we have the day of the week that you were born in. We have iPhone, Android, or other, which might mean you don't own a smartphone, for example. Any questions on the question? Any questions? Okay, so again, we'll probably find statistically significant evidence if you believe in astrology. When you're born, does that really have anything to do with your personality and life and everything you end up doing? Okay, so I don't know if you know which day of the week you were born in, but it may have all the difference in terms of whether or not you own an Android, an iPhone, or another kind of phone. And this is an example we'll find out. And this is a typical thing to find out if you want to check to see if something's true, if someone tells you something. Okay, this is very different than the others that we did, because notice in this case, we have a table of data that's given. We're not comparing 2 groups. We're looking at just a bunch of people. We're asking them 2 questions. They're both qualitative questions, and we have a table on how many answered in each cell of the question. Any questions on that? Okay, so one thing is, it says there's a relationship between. That's not the word we're going to use in our null and alternative hypotheses. So be careful. I often test you on these kind of things, and you need to know that don't use the word relationship, even though it says relationship. Instead, we're going to use, let's do it in red actually. It's not a goodness fit test. It's not a test for homogeneity. This is a test for independence. Because we want to find out whether the day of the week you were born in and the type of smartphone you own are independent or not. All right, so now let's go ahead and write down our null and alternative hypotheses. Again, this is going to be different in terms of the keywords to use. So first, H naught. That's the same as always is. You always write H naught. And what we say is the day of the week of, I'm just going to write birth, and the smartphone type are independent. And H1 is the day of the week of birth and the smartphone type are dependent. Notice the words independent and dependent. Those are required in H0 and H1 when you're doing a test for independence. I will take off points if you don't put those in. Any questions at all on H0 and H1? Any questions? Here's the good news. The good news is it turns out the mathematics behind test for independence and test for homogeneity is exactly the same. Even though H0 and H1 look very different, the math is the same, which means the calculator work is exactly the same. So let's go and do our calculator work. So let's go to matrix, because it's exactly the same. Second matrix. Then I'm going to go ahead and edit the matrix A. It's not a 2 by 3. We have 3 rows and 7 columns. So it's a 3 by 2, 3 by 7. And then I start typing in 75, 72, 68, 77, 70, 86, 80, and then 120. Oops, didn't get it though. If I type too fast, it doesn't read it. 111, and then 131, and then 118, and then 124, and then 101. Did I miss one? Looks like I missed one. Let's look at it again. So 120, 111, 131, 125. There we go. Then comes 118, 124, 101. Much better. Then 45, 52, 44, 50, 57, 57, 46, and 52. Okay, again, this is exactly the same in terms of the way we get our p-value. Next, we go to stat, tests. We go up to chi-squared test, exactly the same as the last example. And hit enter. Observed as A, expected as B. And then enter on calculate. Okay, what do you think? Our test statistic is 9.06 about, chi-squared is 9.06. Our p-value is 0.7. So what do you think we can conclude? Yeah, definitely not statistically significant, which, by the way, I can't imagine anyone thinking they would be, that the day of the week you're born on has anything to do with what kind of smartphone you have, but I put this in for fun. Yeah. I made up these numbers, by the way, don't quote me, but I would guess that you would get a very high p-value if you tried this yourself. So we can write that there is statistically insignificant evidence to make a conclusion about whether or not the day of the week of birth and the smartphone type are, you could write independent or dependent, doesn't matter since it's insignificant. Maybe I'll write dependent. Okay, if there is evidence, then you have to write dependent. Any questions about a test for independence? What do you think the hardest part about these problems are going to be on the final exam? Any thoughts? Because I know, because I've given this final many, many times, or given a final in this class. Yeah, exactly. Which test to use? Okay, that is the hardest part. So let me reiterate. Okay, if you want to test if a unknown distribution is the same as a known distribution, then it's goodness of fit. If you want to test if two distributions are the same as each other, and both are unknown, then it's homogeneity. If you have two survey questions that are qualitative, and you want to find out if they're independent or dependent for the answers, then you use a test for independence. Okay. If it is a quantitative survey question, then it's like chapter 9 or 10. So keep that in mind. And we'll have some more stuff too coming up in chapters 12 and 13. But for now, since we're at the end, what I need to do is give you a secret word. And the secret word for this webinar is distribution. Because remember, when you have a goodness of fit test, you must use the word distribution in your H0 and H1. And even a test for homogeneity, you use distributions. But don't make a plural, it'll mark you wrong. And that's the secret word for this week's webinar. So let me unshare. That's all I have to say about chi-square tests. Next week, we're going to be doing regression analysis. Really important. Okay, it's something you'll recognize, but you won't have seen the mathematics of it, or at least the statistical language for it. You won't see the mathematics next week either. You'll just see the statistical language and how to use a calculator. But this week, it was all about the qualitative data and how to analyze qualitative data, at least testing to see if distributions are the same, or to test if two different qualitative questions are independent of each other. The answers are independent. So as always, Tia or Ross or Zach or Alex, be happy to answer any questions you might have. Be fine saying goodnight too, whatever works for you. But let me know if you have any questions, and then we'll I'll be happy to answer. It could be about the project, could be about chi-squared, could be about anything you have. Okay, so thank you, Ross, for showing up and participating. And Zach, we've got it, I don't know if you've been paying attention to emails, but we've got a solution for you in the library. You just have to ask the librarian to send you the PDF of somebody's post, and they can do that. They have to be there, though. And then you could post just using Google Scholar. Because this week is going to be a discussion discussion assignment where you have to go and find a article that is peer reviewed. This is the last week of doing that. Next week won't have to be peer reviewed. This one has to be peer reviewed because chi-squared is peer reviewed. Okay, what were you saying at the beginning? Okay, I think I'm going to stop sharing, if that's okay, because it's personal and I don't think you want everyone in the world to hear. Let me pause and stop recording. We'll call it a night. And let me say goodnight to all of those who are watching this as an archive webinar. Thanks for watching. Don't forget to post your secret word. And please give me any questions you might have. And post it on the project discussion forum or the Q&A forum, whichever is applicable. So let me stop recording. Yes, you receive an email notification when the cloud recording is ready. Good.